Now that we know how to find the general solution to a differential equation, we want to learn to find the particular solution. So you can see here that the only difference is we're given the differential equation, but we're also given an ordered pair to go with it. That ordered pair is what's going to allow us to figure out the value of the unknown constant. So the first thing we're going to do is solve it for the general solution. So we're going to cross multiply there. We have dy equals x squared minus 1 multiplied by dx. Then we'll take the integral of both sides, and the integral of dy is just y equals, and that would be 1/3 x cubed, right? 1/3 x cubed minus 1x, yeah, plus the unknown constant. So this right here is our general solution. And if we weren't given any additional information, we would have to stop there. But we know that when x is -1, y is +3. So we can substitute those values in, and it will allow us to find that missing constant of integration. So we'll plug +3 in for y and -1 for x. Be careful when you do this. A lot of people get in a hurry and they put the -1 here. But you have to make sure you're putting it for the appropriate variable. This is x, this is y. So we're substituting in 3 for y, -1 for x. And we're going to clean that up and solve for our missing constant. So we have 3 equals, -1 cubed is -1, so we have -1/3 plus 1, which is 2/3
Yep.
plus our constant. And then if we say 3 minus 2/3,
7/3.
that would be 9/3 minus 2/3 is 7/3. Great. Now, that is your constant of integration. But that is not your particular solution. That's just your constant. Our particular solution, we need to go back to right here and say that y equals 1/3 x cubed minus x plus our constant, which we found to be 7/3. So the entire equation is the solution, not just the constant of integration. So for this one, we're going to look at dy dx equals 2 square roots of x at the point 4, 12. So we'll start by splitting this into dy equals 2, and instead of square root of x, I'm going to go ahead and write it as x to the 1/2 dx, so that it makes it already in integrable form. Integrate both sides. This one will become y equals, now it will become 2x to the 3/2 multiplied by 2/3. So we'll write down our x to the 3/2. We already have a 2, and we'll divide by the new power, which is the same as multiplying by the reciprocal of 2/3, which would give us 4/3.
Yep.
So we have 4/3 x to the 3/2 plus c. So this would be our general solution. But we're aiming for our particular solution. So now we're going to substitute 12 for y and 4 for x. So we have 12 equals 4/3 times 4 to the 3/2 plus the constant of integration. So the 4 to the 3/2 power is the same as the square root of 4, which is 2 to the 3rd power, which is 8, multiplied by 4/3, which is 32/3. And then we subtract 12 minus 32/3 is 36 minus 32/3, which is 4/3. So our constant of integration is positive 4/3. And we will substitute that into our general solution, and then we will have our particular solution. So with y equals 4/3 x to the 3/2 plus a constant of 4/3. And that is our particular solution. And we could check that by taking the derivative, right?
Correct.
And once we took the derivative there, yeah, it should match back up to 2 square roots of x.
How would that be 8 though, the 4 to the 3/2? Because when you put it in the calculator, it gives you like a decimal.
Well, 4 to the 3/2 power is the same as the square root of 4. The bottom is the power, is the radical, and that is the power. So the square root of 4 is 2, and 2 cubed is 8. So if you put it in correctly, your calculator should be able to do that. It should be able to give you an 8 out of there. We can pause and look at it.
Okay.
There is another type of notation you need to be aware of for differential equations, and that's rather than the dy dx, or the differential format, it's when we're given in function notation. So for this one, we're told that g prime of x, which really just means that the derivative of g with respect to x, is equal to 6x squared. So it's a little more difficult to kind of like see the differentials there, but the way you have to think of it is that g prime of x is the same as g of x. It's like the derivative of g of x over dx, like that, with respect to x. So this notation really just means this. And that's what equals 6x squared. Another thing you have to be on the lookout for in this problem is a lot of people look at the given constraint there, and it says that g of 0 equals -1, and they get confused about which ordered pair that is. Is this 0 -1 or -1 0?
-1 0.
Which is it? Which one's the x? The one that goes in the parentheses, or?
-1.
The one in the parentheses is the x. So be careful because people want to get that backwards all the time. Always remember the one in the parentheses is the x. So that's your x, and this is going to be your y or your g of x. So be really careful with that. And it is important that you stick to the original given variables. They didn't give you a y, so there shouldn't be a y in your answer. We need to go ahead and split this and say that like the derivative of g of x is equal to 6x squared times dx. And then you just integrate both sides. And the derivative of g of x will just be, yeah, if that were a y, it would just be y. So it's just going to be g of x. Remember that function notation just takes the place of the y equals. So instead of just y, we're going to have g of x equals. And then this integrates up to 6x cubed over 3, which would just be 2x cubed, plus whatever our constant of integration is. So most people do pretty well. They get to this part, and then they just kind of seem to get confused about where to substitute the 0 and the -1. Just remember that the one in the parentheses goes in for x. So the 0 goes in for x, and this is going to be your y or your g of x. So -1 equals 2 times 0 cubed plus the constant of integration. So it really just looks like -1 equals 0 plus c. So our constant is just -1. When we're finished, we will take our general solution and substitute our constant of integration, and that will give us g of x is equal to 2x cubed minus 1. And we could always check that, and I think this time we actually will. We'll switch colors here, and we'll check it. If I take the derivative of g of x, what do I get?
G prime of x.
G prime of x is equal to 6x squared, which is exactly what I had for my original differential equation. Now, if you want to check this guy, he goes into the original. Notice that that says if I put 0 into the original, it equals -1. So let's plug 0 into the original. This is our original function right here. This is our differential function. So if I plug 0 in, what do I get?
-1.
So you should be able to check everything as you work through these. For our final example, we're going to solve f double prime of x equals x squared, which means we have to bring it up from the second derivative up to the original function. We also know that the first derivative, when evaluated at 2, is equal to 5. And the original function, when evaluated at 0, is equal to 3. So we're going to start with f double prime of x equals x squared. And we're going to integrate it once. And technically when we integrate, we should put a differential on there. So we'll put a dx on this side because we understand that that is the derivative with respect to x there. And if I integrate up once, I'm up to the first derivative. Yeah, that brings me up to the first derivative, and I get 1/3 x cubed plus some constant of integration. Now that's not my general solution because I'm still at the first derivative. It's technically not a solution until it arrives at the original.
So we have to do it again.
So now we're going to substitute in 2 for x, 5 for f prime, And that will allow us to find our first constant of integration. So 2 for x, 5 for f prime. Five minus 8/3 is 7/3, correct? So we see that our first constant of integration is 7/3. So now we know that f prime of x is equal to 1/3 x cubed plus 7/3. Do we have any questions so far? All right, so what should we do now?
You do it again. You go.
Integrate again, right? So we'll take the antiderivative of this and we will apply our differential over here. And when we integrate f prime of x, we get the original f of x is equal to, add 1 to the power, divide by the new power, and that gives me 1/12 x to the 4th.
Yes.
Someone double check that.
Mm-hmm.
Yeah.
I'm dividing by 4, it's like multiplying by 1/4, so 1/3 times 1/4 is 1/12.
Yep.
X to the 4th plus 7/3 will become 7/3 x plus our new constant of integration. So that is our general solution. And now we can substitute 0 for x and 3 for f of x. So we have 3 equals 1/12 times 0 to the 4th plus 7/3 times 0 plus the constant. So what's the constant equal? 3. So we know that our constant is 3. And so for our final answer, we have f of x is equal to 1/12 x to the 4th plus 7/3 x plus our final constant of integration, which we found to be 3.